Hi ma'am, hi everyone. We are the group 3 in reporting and we will report about current fields and career of civil engineering. They are the structural engineering, construction engineering and management, geotechnical engineering, water resources engineering, transportation engineering, and environment and energy. First, we have the structural engineering. Good morning, ma'am. Today, I'll report about structural engineering. Structural engineering is a subdiscipline of civil engineering in which structural engineers are trained to design the bones and muscles that create the form and the shape of man structures. Structural engineering design uses a number of relatively simple structural concepts to build a complex structural system. Sinasabi dito nga, ang structural engineering ay isang subdiscipline daw ng civil engineering kung saan ang mga structural engineer ay sinasanay upang magdisenyo ng mga buto at kalamnan na lumilikha ng anyo at hugis ng isang struktura gawa ng tao. Sila daw yung nagdidisenyo or nagpaplano ng buto at kalamnan ng isang structural. Kunwari sa isang building, sila nagdidisenyo ng buto at balat. Kumbaga pinaka-foundation. Ang disenyo ng struktura ay gumagamit ng ilang medyo simpleng konsepto ng struktura upang makabuo ng mga komplikadong sistema ng struktura. Structural engineering theory is based upon physical laws and empirical knowledge of the structural performance of different materials and geometries. Structural engineering design utilizes a number of simple structural elements to build complex structural systems. Ang teorya ng structural engineering ay batay sa mga physical na batas at empirical na kaalaman sa pagganap ng struktura ng iba't ibang materyales at geometries. Ginagamitan daw ito ng materyales, tapos geometries para mas matibay. Next. History of structural engineering. Structural engineering dates back to 2700 BCE when the step pyramid of Paro Dihauser was built by Imhotep, the first engineer in history known by name. Pyramids were the most common major structures built by ancient civilization because the structural form of pyramid is inherently stable and can be almost infinitely sealed, as opposed to most other structural forms which cannot be linearly increased in size and proportion to increased loads. Yung structural engineering daw may nagsimula noong 2700 BCE or before the Common Era ang step pyramid para kay Paro Dihauser. Pinakaunang ginawa ng struktura ay si Paro Dihauser at kanyang ay itinayo ni Imhotep, ang unang inhinyero sa kasaysayan na kilala sa pangalan. Ang pyramid ay ang pinakakaraniwang pangunahing struktura na itinayo ng mga sinaunang sibilisasyon dahil ang struktura ng anyong na isang pyramid ay likas na matatag at maaring halos walang hanggang sukat. Ang pyramid daw ay matatag at walang halos at hindi masusukat kumpara sa karamihan ng iba pang mga estrukturang anyo na hindi maaring linear na dagdagan ang laki sa proportion at tumataas na mga karga. Yan yung history of structural engineering. Si Imhotep, yung kanang kamay ni Dihauser, siya yung gumawa ng pyramid para kay Paro Dihauser. Next. Galileo Galilei published the book Two New Sciences in which they examine the failure of simple structures. Si Galileo Galilei, tinathala niya ang aklat na Two New Science kung saan sinuri niya ang mga kabiguan ng mga simpleng struktura. Next, si Isaac Newton naman, ma'am. Isaac Newton published Philosophy Naturalis Principia Mathematica, which contained his law of motion. Si Isaac Newton naman, ilathala niya ang Philosophia Naturalis Principia Mathematica na naglalaman ng kanyang mga batas na pagdalaw. Next is Leonard Euler developed the theory of buckling columns. Binuo naman niya ang theory ng buckling of columns. Next is structural failure. Structural failure. The history of structural failure engineering contains many collapses and failures. Sometimes this is due to obvious negligence, as in the case of Pettitonville School collapse, in which Ray 14 Augustine constructed the building all by himself, saying he did not need an engineer as he had good knowledge of construction, following a partial collapse of the 3-story schoolhouse that sent neighbors fleeing. The final collapse killed 94 people, mostly children. Makasaysayan ng structural engineering daw ay naglalaman ng maraming mga pagbagsak at pagkabigo. Minsan ito ay dahil sa halatang kapabayaan, tulad ng kaso ng pagbagsak ni Pettitonville, kung si Rev. 14 Augustine nagtayo ng gusali ng mag-isa na nagsasabing hindi niya daw kailangan ng isang ininyero dahil mayroon siyang mahusay na kaalaman sa kontribusyon. Kasunod ng bahagyang pagbagsak, 3 palapag ang schoolhouse na nagpatakas sa mga kapitbahay. Ang muling pagbagsak ay pumatay na 94 na katao, karamihan ay mga bata. In other case, structural failure require carefully study, and the result of these inquiries have resulted in improved practices and a greater understanding of the science of structural engineering. Some such studies are the result of forensic engineering investigation, where the original engineer seems to have done everything in accordance with the state of the profession acceptable practice, yet a failure still evaluated. A famous case of structural knowledge and practice being advanced in this manner can be found in series of failures involving box windows which collapsed in Australia during the 1970s. Sa ibang mga kaso daw, ma'am, ang mga pagkabigo sa struktura ay nangangailangan ng maingat na pag-aaral, at ang mga resulta ng mga pagtatanong na ito ay nagresulta sa mga pinahusay na kasanayan at higit na pag-unawa sa agham ng structural engineering. Ang ilan sa mga naturang pag-aaral ay resulta ng mga pagsisiyasat ng forensic engineering, kung saan ang original na inyero ay tila ginawa ang lahat alinsunod sa estado ng profesyon at katanggap-tanggap na kasaysayan, ngunit kabiguan pa rin. Ang isang tanyag na kaso kalaman sa struktura ay kasanayan na sinusulong na ganitong paraan ay makikita sa isang serya ng mga pagkabigo na kinasasangkutan ng mga box grinder na bumagsak sa Australia noong 1970s. Next naman is materials. Structural engineering depends on the knowledge of materials and their properties. In order to understand how different materials support and resist loads, it also involves a knowledge of corrosion engineering to avoid, for example, galvanic coupling of dissimilar materials. Sa ibang mga kaso, ang mga pagkabigo sa struktura ay nangangailangan ng maingat. Ang struktura ay nakasalalay sa kaalaman ng mga materyales at ang mga kanilang katangian upang maunawaan kung paano sinusuportahan, nilalabanan ng iba't ibang mga materyales ang pagkarga. Nagsasangkot din ito ng kaalaman sa corrosion engineering upang maiwasan ang halimbawa ng galvanic coupling na hindi magkatulad ng materyales. Ang mahalaga ito, ma'am, para may tayo ng maigi at maigi ang struktura at matibay, hindi agad matutumba. Ang halimbawa dito sa natural materials, structural materials are wrought iron, cast iron, concrete, reinforced concrete, press-stress concrete, alloy, steel, stainless, mill, masonry, timber, hardwood, softwood, aluminum, composite materials, plywood, Other structural materials, adobe, bamboo, carbon fiber reinforced plastic, mud brick, cooling materials. Yung mga mga halimbawa ng materyales na matitibay na pwedeng itayo, pwede gamitin ng mga structural engineering upang matibay isang struktura. Yan lang. Thank you.
Construction, engineering, and management. Construction, engineering, and management refers to the use of critical thinking in technicals and scientific fields to improve a construction project. This often involves designing and executing new solutions and faster processes that can help overcome work sites obstacles and improve efficiency. Construction, engineering, and management can help improve safety, productivity, natural disaster resilience. Any aspect of the construction industry could be addressed by the construction, engineering, and management. Also, construction engineering and management involve the applications of technicals and scientific knowledge to the infrastructure construction project. The construction engineering management blends engineering, which focuses on design, with construction management, which is concerned with overseeing the actual construction. Some common areas of focuses of the construction engineering and management include the commercial business or housing construction, electrical system design, HVAC, mechanical, highway or heavy construction, which include the bridge building, airport design, and waterways management system, etc. The requirements for the construction engineering management must possess a thorough understanding of laws, regulations, and building codes, especially those that have direct impact on the project at hand. They must also able to estimate the total cost of the given project with considerations to number one, you have the sites and inspections. Two, we have the drainage, sewage, and elevation level tests. Third one, we have the equipment and materials. And lastly, the labors. Construction engineering manager also responsible for managing the working of various of other entities involved in the project. They are responsible for providing expert supervision for beginning to the end while also keeping the project running on or ahead the schedule and within budget. The job requires strong leadership and interpersonal skills and attention to details. Like any other kinds of engineering, construction engineering managers need to possess a strong problem solving, analytical, and mathematical skills. The construction engineering management is applied throughout the project lifespan from the initial planning stages to construction labors to project completion. A job opportunity related to the construction engineering management are expected to grow almost twice as fast as the average across the whole job market.
Good evening, ma'am. Today, I'm gonna report about geotechnical engineering. Geotechnical is an engineering discipline that deals with soil and rocks behavior in an engineering perspective. It also involves assessing slope, stability, and the risk of landslides, rockfill, and avalanches. Sinasabi dito na ang geotechnics daw ay isang disiplina sa inhenyero na tumatalakay sa pag-uugali ng lupa at bato sa isang pananaw sa engineering. Kasama rin dito ang pagtatasa ng katatagan ng slope at ang panganib na pagguho ng lupa, pagbagsak ng bato at pagguho. Sa geotechnical engineering ma'am sila nagsusuri sa lupa at bato sa isang slope. From a scientific perspective, geotechnical engineering firstly involves definiting the soil's strength and deformation properties. Clay, silt, sand, rock, and snow are important materials in geotechnics. Geotechnical engineering includes special fields such as soil and rocks mechanics, geophysics, hydrogeology, and associated disciplines such as geology. Geotechnical engineering and engineering geology are branch of civil engineering. Um, Sinasabi naman dito na mula sa siyentipong pananaw daw, ang geotechnical engineering ay higit na nagsasangkot na pagtukoy sa lakas ng lupa at mga katangian ng pagpapapangit. Clay, ang clay daw, silt, buhangin, bato at niebe ay mga mahalagang materyales sa geotechnics. Kasama sa geotechnical engineering ang mga espesyalistang larangan tulad ng mekanika ng lupa at bato, geophysics, hydrogeology at mga nauugnay na disiplina gaya ng geology. Ang geotechnical engineering daw at engineering geology ay isang sangay ng civil engineering. Next is NGI and Geotechnical Consulting. Geotechnics is applied when planning. Geotechnics is applied when planning infrastructure such as suites and funnels as well as buildings and other construction onshore and offshore. This discipline also involves performing numerical calculation, analyzing the stability of slope and cliffs and assessing load-bearing capacity, settlement and deformation in man-made structures. Sinasabi naman dito inilalapat ang geotechnics kapag nagpaplano ng infrastruktura tulad ng mga kalsada at lagusan, pati na rin ang mga gusali at iba pang mga construction sa pangpang at malayo sa pangpang. Kasama rin sa disiplina ang pagsasagawa ng mga numerical calculations, pagsusuri sa katatagan ng mga slope at cliff at pagtatasa ng load-bearing capacity, settlement of deformation sa mga strukturang gawa ng tao. Next naman is NGI and Geotechnical Research and Development. NGI conducts research and development in all of the fields mentioned above. NGI receives some annual grants for this research from Research Council of Norway. NGI's geotechnical expertise is used to assist both the authorities and private enterprise in the following markets: offshore energy, natural hazards, building construction and transport, environmental technology. Ang NGI ay nagsasagawa ng pananaliksik at pagpapaunlad ng lahat ng larangan. Nabanggit sa itaas, ang NGI ay tumatanggap ng taunang gawad para sa pananaliksik na ito mula sa Research Council of Norway. Ginagamit ang geotechnical na kadalubhasaan ng NGI para tulungan ang mga otoridad at pabribadong negosyo sa mga sumusunod na merkado. Ito ang mga offshore energy, natural hazards, building, construction, and transport, environmental technology. Next is si Carl Terzaghi. Sino nga ba si Carl Terzaghi? The scientist geotechnical engineering was permanently developed by the Australian Carl Terzaghi in the early 20th century. He was professor at the Vienna University of Technology and later at Harvard University. Before his death in 1963, he dedicated all his technical and scientific material to NGI. His works are held by the Terzaghi Library at NGI, which opened in 1967. Sana si Carl Terzaghi. Ang agham daw ng geotechnical engineering ay pangunahing binuo ng Austrian na si Carl Terzaghi noong unang bahagi ng ika-20 siglo. Siya ay isang professor sa Vienna University of Technology at kalaunan ay lumipat sa Harvard University. Bago ang kanyang kamatayan noong 1963, pinamana niya ang lahat ng kanyang technical at siyentipong material sa NGI. Ang kanyang mga gawa ay hawak ng Terzaghi Library sa NGI na binuksan noong 1967. Si Carl Terzaghi ay nabuhay noong October 2, 1883 at namatay noong October 25, 1963. Yun lang. Thank you.
Hi everyone, my name is Dunita Picarara and my topic is all about water resources engineering. So what is water resources engineering? So water resources engineering is a specific kind of civil engineering that involves the design of new systems and equipment that help manage human water resources. So it's about managing, sustaining, or preserving the water human resources by developing new systems and equipment and or solutions for the water related issues. So water resources engineering generally deals with the provision of water for human use and the development of techniques for the prevention of destruction from floods. Water resources engineering also includes the planning and management of facilities that are constructed for these tasks, like making canals for irrigation and sewers for drainage and to avoid waterlogging, and all other issues related with the usage and control of water. So it is about controlling the water resources and making practical methods for the current or future problems our engineers may face. So what is the importance of water resources engineering? So I'll give you a little trivia. So did you know that the Earth planet was known as blue planet because 71% is covered by water and only 0.3% is the amount of water that can only be used by humans. So as been said earlier, 71% of the planet is surface water. At the same time, though, just 3% of the Earth's water is fresh, according to the Bureau of Reclamation. And of this total, 2.5% is out of reach, contained in the soil, polar ice caps, the atmosphere, and glaciers are too polluted to use safely. So, water resource engineers may be charged with developing new systems or processes for private or government entities that can preserve fresh water sources and find new ones. This may require the assistance of civil engineers involved as well, designing water purification methods through desalination or creating new equipment for contaminant transport when water is used for irrigation purposes. So, they are also involved in water treatment so that the quality of water may improve for various systems or uses. So, what is the role of engineer? So, aside from what has been said earlier, water resources engineers fulfill a wide variety of roles in designing and managing water-based systems. These roles include designing major water distribution systems that transport water to water users, and collection systems that convey waste and stormwater, managing surface and groundwater resources, metering and quantifying flows in rivers and streams, modeling and designing major water resources projects like canals, reservoir, and hydroelectric works, and many other work-related engineers functions. So there are a lot more beside than that. So like the civil engineering, the water resources engineering have also its subdiscipline. These are the irrigation engineering, coastal and river drainage design, flood control, groundwater hydrology, water resources management, hydraulic structures, and many more. So we conclude that limited availability of fresh water, increasing water demands, and continuing development pressures in flood-prone areas all punctuate the need for well-educated, well-equipped water resources engineers. So that's that's all, and thank you for listening.
Transportational engineering. What is transportational engineering? Transportational engineering is a branch of civil engineering that is involved in the planning, design, operation, and maintenance of safe and efficient transportation system. This system included roadways, railways, waterways, and intermodal operation. Typically, the demand in the amount of traffic that is expected to use a particular transportation facility, while the supply in the quantity are type of infrastructure component. These systems are typically large and expensive. Important aspect of transportation engineering is that the transportation engineering is not only interested in the infrastructure and the individual units that use that infrastructure but also the user. All three of these infrastructure, individual units, and user to understand the system as a whole. Typically, the infrastructure in units are considered the supply of the equation, while the user are identified with demand. What does a transportation engineering do? In general, the transportation engineer can work as transportation planner, traffic engineer, railroad, shipper, or transportation consultant, etc. Their main responsibility through plan, design, build, operate, and maintain system of transport will be resolved to a safe, efficient, and convenient movement of people and merchandise. Structure engineer are called guardian of structure. CEM are called builder of structure. The transportation engineer called transport keeper or infrastructure. Some more of the component of responsibility are the development, the transportation strategies, design our highway, airports, railways, transport system, making sure that the transportation plan comply with engineer standard and construction policy, etc.
Energy and environmental engineering is a branch of energy engineering which seeks to efficiently use energy and to maintain the environment. Energy engineers require knowledge across many disciplines. Careers include work in the built environment, renewable and traditional energy industries. In this area, solar radiation is important and must be understood. Solar radiation affects the Earth's weather and daylight available. This affects not only the Earth's environment but also the smaller internal environments which we create. Energy engineering requires at least an understanding of mechanics, thermodynamics, mathematics, materials, stoichiometry, electrical machines, manufacturing processes, and energy system. Environmental engineers solve problems. They invent better ways to recycle paper, plastic, and glass. An environmental engineer may also help come up with ways to treat water that is contaminated by bacteria and chemicals that could be harmful to our health and to the environment. Environmental engineering can be branched into two main areas: internal environments and external environments. Internal environments may consist of housing or offices or other commercial properties. In this area, the environmental engineering sometimes stands for the designing of building services to condition the internal environment to a comfortable state or the removal of excess pollutants such as carbon dioxide or other harmful substances. External environments may be water courses, air, land, or seas, and may require new strategies for harnessing energy or the creation of treatment facilities for polluting technologies. This broad degrees area covers many areas but is mainly mechanically and electrically biased. It seeks to explore cleaner, more efficient ways of using fossil fuels while investigating and developing systems using renewable and sustainable resources such as solar, wind, and wave energy.